Welcome, welcome, welcome. Welcome back from your well-deserved holidays. This semester, we will conduct e-lecture and e-tutorials. We have not done that before, and obviously will have many setbacks and frustrations along the way. But we will learn, improve, and adapt as we progress. My name is Mr. Louis, and here are my details. I will start a WhatsApp group for all to discuss on the module contents as time progress. These are the approach that we're going to use this semester. How the tutorial, which might be e-tutorial, is still an unknown, and how is it going to be conducted is still in development during this video time. The laboratory, whether E or not, is still an unknown, and we will be very clear, rather crystal clear when the term begins. This is the assessment metrics which were done during the past few semesters, and we will be following it as closely as digitally as possible. I do not know what is likely to change, but we'll try to keep it as this form. Now, in all, this module has 12 lectures. 12 e-lectures to be exact. The first topic has 1 lecture. Limits, fixed, and tolerance will have 2 lectures. And this is 3 lectures. And that is 4 lectures. Analysis of this is 2 lectures. Design for static strength is used to be a e-learning topic, and will likely stay as it is, e-learning. E-learning is self-learning. There will not be any e-lecture for this topic. So let's begin with the first lecture. First e-lecture. The topic here is called Introduction to Mechanical Design and Engineering Design Process. So let me start this e-lecture. On a piece of blank paper, I'm going to use blacking. To begin, we must have a need. To begin to design anything, there must be a need. And let me give an example. Let's say there's a need to move with speed. While standing, wow. That means you are standing and you want to move with speed. So maybe you think that was the MRT, but it's not. It has to be no external energy. So there must be a need. And with the need, we will come back with a problem. So let's say that's the first thing. Mark out, this is the first step. You must have a need. Then let's move on to the second step. With the need, you come and define the problem. A problem statement. So a problem statement will be like that. I want to design a board to move with human power. So that is the statement. So now that's the second phase. Now let's get to the third phase. The third phase, we call it synthesis. Synthesis is like a dreamer, no? You dream about it and you analyze it thereafter. Example is this, if I want to do a bot with human power, I may want to have a bot like that. I may dream of it, let's say you have a bot like that. Then onto this board, I want to have the wheel. And another wheel. That's one of the concept. Then another guy will think that, okay, let me have it this way. Why do I need to have two wheels? I mean, two pair of wheels. Why not I have just a single wheel? This phase is called the synthesis phase. You can dream about it, what you want. And let's assume that, let's say I want to have the wheel. Then I say, hey, why don't I have a bigger wheel? So I would think of it this way. A board and bigger wheels. So maybe that big. So this phase is called the synthesis phase. So let me just draw the boundary here. You see there are three steps there. The first three steps are written here. Need, problem, and synthesis. Now we come on to the more serious thinking in engineering. It's called the analysis and optimization. This is the bulk of the module. We actually focus this heavily, and let's understand what is this all about. This is purely a hardcore engineering. No more dreaming. Imagine I got a board, and the guy standing on the board weighs 50 kg. And you know, in engineering, we will not use kg, we use Newton. So that, let's say, is equal to 500 Newton. 500 Newton, why did I get 500 Newton? Because I assume G equal to 10 meter per second squared. That's assumption. So now I realize that there is a 50 kg coming down or 500 Newton coming down. There will be two reaction force over here. I'll call it R. Looking at it intuitively, if this is 500 Newton coming down, the force here will be 250 Newton. Now, more to it, let's look at this guy now, to this board here. This board has to have a certain material. So which material we're going to do, which we will select, will depend on analysis and optimization. So what are the material available? Maybe we can say wood, maybe we say steel, aluminum, or what have you, and maybe make it light plastic. So this is the part of the analysis and optimization phase. Now, if someone step on it and we realize that this guy will deflect, someone stand on it and it deflects. This is called the deflection. Now, it's interesting to talk about deflection. We ask ourselves what determines the deflection. So we say, okay, we can have the load, that means the heavier the passenger on it, the heavier is the deflection. The higher is the deflection, and we can say the length. Now, what do you mean by the length? Length means from here to here. That's the length. Then we might come and say, now, if the length is an effect, what about the thickness? Thickness. So thickness will be here. Thickness will play a part. On top of that, then we say, what about the width of the board? So the width of the board will be this, will be here. Let's say the board is this. So this will be the width. And maybe we should not miss out the material. Oh, that's beautiful. You see, the material is here. And this material actually comes up from here, you see? So the material play a part over there. Now let's say that we already handled this and we need to analyze more, and since it's a vehicle, we need to know the diameter of the wheel. Let's just discuss about the diameter of the wheel. Let's say I have I'll take this space here. I have a board. And let's say I have a small wheel. Or maybe I have a big wheel. Now, which is the correct size then? So now we need to analyze further. Small wheel. When the wheel is small, what is the problem? So maybe it cannot roll over a step. Invert a small step. So that's a problem. Then I want to have the wheel as big as possible. So big. So if it's big, any problem with big? Okay, interesting. Because we have another problem. The leg length is similar. What do I mean by that? Assuming you have one leg on the floor and another leg on the board, can you see the problem? So basically, you cannot have too big a wheel because your leg length is similar. Finally, let's say let's look at the board surface now. Let's look at the board surface and say now this is a board. What about the surface? And you know that on this surface we have roughness. In engineering we call it friction. So what does friction depend on? So friction actually is equal to mu n. So in short, you realize that during the analysis and optimization phase, we are looking at the engineering aspects of the design. I will stop here and I will change the paper and continue my video.